All right, folks, we're in section 13.2, one-way ANOVA. In this sequence of problems, this is problem number 2, dealing with blood pressure. Let's go ahead and read this. A medical researcher wishes to try 3 different techniques to lower blood pressure patients with high blood pressure. The subjects are randomly selected and assigned to one of 3 groups. Group 1 is given medication, Group 2 is given exercise program, and Group 3 is assigned a diet program. At the end of the 6 weeks, each subject's blood pressure is recorded with the data shown below. Use a p-value and a level of significance of 1% to test the claim that the mean is the same for the different groups. It is shown that the distribution of blood pressures within each group is normally distributed. Alright, so starting off with each one of these, group number 1 is the medication group. So they're the one that received the meds. Group number 2 is the exercise group. So we got group number 2, exercise, and then group number 3 is on a diet. Looking at that, it says recorded at the end of each of those 6 weeks there, the blood pressure is recorded again and listed here. And so blood pressure is measured in milligrams per deciliter for 2 numbers. You have an upper number or a top number and a bottom one. And I think they're just probably talking about the top number. But really both numbers go hand in hand. Those that know things about blood pressure, particularly you get older, you got to monitor this kind of thing here and whatnot. But some conspiracy think that it's all just made a bunch of wacko science anyway, and so you shouldn't have to really worry about it too much. Maybe some of that is true, but let's go and collect here for the problem here. This is the set. Again, here the set of all blood pressures, and I'm just assuming the top number. So the set of all blood pressures of patients and we'll list it here. So for group 1 or using the it says given or using the medication. So pretty much copy and paste that for the others, and of course change that slightly over to involved with population number 2 is the exercise group. So given or using, I'll put here using an exercise program. And then the last one is recorded a diet program. So you got some medication, exercise, and then diet. So I'll just put here, changing that to using a diet program. Done. Okay. So it looks like each one of these groups is given some sort of experiment. We don't have one group, and we certainly could have another group, perhaps group number 4, which wasn't given anything at all. In other words, the placebo, the sugar pill, whatever you want to call it, as the control group. So it seems here that each one of these are experiment groups, and there is no procedure part of this to expose a control group. They should have probably done that in this sort of example. These are, we try to keep it pretty close to realistic, other than The other one was, the sorority house thing was, probably just made up numbers or something like that. In terms of, psychology or, the, medical field or something like that. So all definitely applicable stuff there. So from the beginning here, so in other words, I want to point out they could have put a control group in there, but they decided not to do that. But anyway, we just have the 3 experiment groups there. That's okay. We're going to assume off from the beginning that all 3 of those, on average, for their blood pressures are all the same. So in other words, I'm saying that from the beginning here, that we're going to assume that nothing stands out to be different. It don't matter if you give them the diet or whatever it is, it's all the same. But we want to try to show that at least one of those stands out to be different. Does the medication stand out to be different from the exercise group, from the diet? Which one stands out to be different? And here in that case, that at least one or maybe at least 2, or okay, I should say at least 1 or maybe 2 of those stands out to be different, causing that change, that dramatic change in variance, which is again why this is called ANOVA. So definitely go back to that first example I did with the sorority house, mapping all this, talking about these concepts over here of the idea, what they mean when you look this stuff up. What does it mean by the between when they use that language versus the language of within? And so just, really briefly here, when they say between, that's jumping from one group to the other group to the other group. In other words, we're trying to say that we have 3 groups here, then the degrees of freedom would be 3 minus 1. But when looking within each group, that's just singling that out. Say with, that for example, if I want to just single out the medication group, that's where I'm looking within or looking at that sample of size 6. So the degrees of freedom of that would be 6 minus 1 would be 5. But anyway, so that's just kind of that language you'll see when dealing with ANOVA. They'll talk about between, versus within and things of that nature. And of course here, ANOVA is an acronym that shorts for analysis of variance, but always used to measure the variation of data to try to offset the fact that the means are the same. But this is always a test of the same means. So jumping back here to step number 2, verify the requirements. So this, we have to have at least an approximate bell-shaped curve for each group. Up there it's stated, it's shown that each one of the different procedures that are used for group number 1, group number 2, group number 3 are normally distributed. So for each, I'll just stay here, for each experiment group, each group, we have a bell-shaped curve, normal, just say normal dist, and therefore that implies we can go ahead and grab F distribution, and that's short for Ronald Fisher. So we got Fisher involved, we got the other guy too, the T distribution, that's Gossett, and then there's another guy, Fisher, Gossett, I'm drawing a blank right now, it's pretty late, it's almost like midnight. It's not coming to me. There's Carl, I can't remember his name. It's not Gauss or anything like that, even though Gauss came with a bell-shaped curve, but that's alright. So let's go ahead and slide here to step number 3 here in breaking that down. I went through that first video with the degrees of freedom and looking at that for the numerator denominator there. So let's start off with, again here, state of the level of significance. Looks like the same as the last problem I did, which is 1%. So we're going to slide in that 0.1 there. Again, no worry about left tail, right tail, two tail. This is going to be always right tail for all these. Very similar to the goodness of fit test, because essentially F random variable is a ratio of 2 chi-square random variables. So very similar to that. Degrees of freedom. So you have the degrees of freedom of the numerator. That's also quote there, the between group. and the formula for that is that's k minus 1. In this case, I've got the three groups, so this would be 3 minus 1, which would be 2. And then we have that degrees of freedom of the within, which is also the denominator for that fraction, and that's going to be equivalent to the number of different categories, again, which is 3, but then you're going to multiply that times the degrees of freedom within each one, which is the 6 minus 1. And so degrees of freedom with each group is 5 times 3. Obviously here you get 15. So our numbers that we're using here, we got level significance. We know that that's going to be that right tail, so we're going to grab that right-facing bracket there on GeoGebra. We're going to throw the 2 in there for the degrees of freedom in the numerator, and that for the denominator. Yeah, so everything changes. Like even the last example I did, that was dealing with 4 groups. This is dealing with 3 groups. They have different sizes. But one thing to point out here, like even when doing this for ANOVA, it is a case that, and then here I'm just going to say that, okay, n is equal to 6 for each one of those groups. You want the sample size to be same for each one, or get the best results there out of ANOVA. Now, could you do this without the same sample size? Absolutely, and there's a way to do that. And also stating this as I did in the last problem, that ANOVA is a test of 3 or more means, but certainly you could do that. You could do an ANOVA with 2 means if you wanted to do that. Not very common. More common would be a t-test, an appropriate t-test to do that, than to use the comparison there for ANOVA. But I'm not saying like people don't do that. They do that sort of comparison along with a control group. So, but this is just a general. This is just so that you get the gist out of it and what's happening with the formulas here. So let me go back over, just jump over to the F calculator on GeoGebra. Let's go and find out that cutoff point there for F. All right, where we go back here, probability. Let's go here, probability again, probability, and F. All right, F distribution, done. Okay, so we got DF1, DF2. So DF1 is the numerator, or the between. So you've got 3 minus 1, that's 2. And next group, you've got 5 plus 5 plus 5, or 3 times 5 is 15. Okay, done. That's your degrees of freedom denominator. Make sure you grab that right bracket there, and then the bottom right box, place in the level significance, which is 1%. And there you go, you got that 6.3589. So 6.3589 is our cutoff point. Past that will prove that the means are not the same. All right, so jump back over here, fill in the blank for this problem. I'll try to make this video as short as possible, because these look like these end videos here are lasting at least 20 minutes, half hour, so they're pretty long stuff. So F naught is equal to, what's that cutoff point? So again, it's 6.3589. So that's our cutoff point. To be past that point proves statistical significance here. All right, so we're going to try to see if we can do that. Let's go ahead and collect some stats here, and again to point this out, that as we're going through this, we have for each one of these groups. So here we have our medication group. You've got your exercise group, and then you got that last one, which is the diet group. So there's your 3 groups there, and from each group we want the sample size, sample mean, and sample variance, not standard deviation. Got to have that S squared. And so we just want to grab these calculators and do that until all for us. Now each one of these groups here does have the same sample size. You do need to do that. Size 6, that's our N for that. So let's go back over to our old calculator.net calculator. Where is it? Looks like it is right here. Already placed this in for group number 1 for the medication group, so I'll just read off the results for that. So our count is 6, our average is 11.3 repeating, or 11 1/3. That very last one, you don't want the sample standard deviation, you want the sample variance there. The 6.6 repeating, or the 6 2/3 there. we'll just kind of cap those off since those are repeating decimals. So those are my stats there for the medication group. I want the sample size, sample mean, and the sample variance. So let me just jot down those numbers there. So again, here for the sample mean, 11.3 repeating, 11.33. So I went kind of two places there because it's dealing with that whole number data. And the next one there, 6 2/3 or 6.67. Excuse me. Sorry. So putting that in for each one of those, you go to the next group there for the exercise program, and now we go from 11.33 to 3.67 average, with a variance of roughly about the same there, 7.47. And the last one there for the diet, that average 7.17, and then for the variance for that was 9.77. So literally doing this by hand. What you want to do, again, kind of like I described in the last video there, is that you want to switch these. Those are all means. You want to find the variance of those numbers, and yet on the other end here for the variances, in other words, you don't want to find the variance of the variances, you want to find the mean, flip that, you want to find the mean of those variances there. So that's literally those numbers are going to literally translate for your solutions here for F and calculating F. And so recall here that F standardized value is the sample size, in this case, which is 6. So you're going to multiply that times that top one there. That is the variance of your sample means. And then divided by, there in the denominator, that's the average, there, the mean of sample variances. So, and that just directly ties one another over here. So what we need to do is dump those numbers back in to figure out the variance of the means, the mean, the variances. So let's go ahead and do that. Let's go back over to calculator.net and doing that for the between group there. So let me go ahead and clear. So let me put in those numbers there, separate that with a comma. Alright, so dealing with the means, 11.3 repeating or 3.3 comma. Next, group number 2, exercise group, was a huge decrease there, 3.67, the 3 2/3, and then finally the last one there is 7.17. Done. Let's go ahead and calculate there. Just those three numbers. Again, I want that bottom one, that 14.7052. So, I mean, we got everything else there, but, because those are all means, I want the variance of those means. I want that bottom one, again, the 14.7052. That's the number I want there. So I'm going to go ahead and record that. Okay, let me jump back over here. So again, filling in the blank here. Again, we know that N is the sample size from each group is 6, and then we just grab that one there. That's that 14 point, what was it, 7, what was that? What was that number? 7052. Alright, great. And we want the one there on the bottom. So I got to go back to clear out that calculator and placing in, let's go back here, placing in each one of those sample variances. The 6 2/3, 7.47, and the 9.77. And then figuring out the average of those three variances. So let's clear that out. Okay, cleared. Done. Alright, so let's put in those numbers again. So we got 6 2/3, 6.67, comma, 7.47, comma, and then 9.77. Calculate. Done. So the average there is that mean 7.97. Again, 7.97. is going to be that bottom combo there. So again, that's just really quickly there using that calculator.net, figuring out the variance of the means. In this case right now, the mean of the variance is that 7.97. Okay, done. So now we're going to do is multiply and divide. So let's go ahead and do that with those three numbers there to finish that out. 4 places there for F. Okay, so we got 6 times 14.7052. Okay, so that one, that combo there, 88 and 88.2312. So again, that's 88. So let's just take the big product there, 88 point, what is that? 88.2312. All right, no problem there. 2312. Okay, done. And then that you're going to take and divide that by divided by 7.97. All right, done. So you got the 11. So we're going to go to 3 places there. 11.0704. So 0704. Okay, that is the standardized value. Are we past the cutoff point? Absolutely. So here we have that evidence to show something stood out to be different than the others in terms of their sample means. And I think if we just kind of slide over here, just looking at what I have highlighted there in blue, no doubt that, I mean, they're all off one another. I mean, particularly, I mean, a huge drop there from the medication group to the exercise group. I mean, these folks are working out there, they're working hard, sweating the oldies and all that. Huge drop there in blood pressure. All right, so that could be one of the other indicators, other than maybe the diet too, showing a complete change there as well from that group. Either being the average of those differences or whatever that is there for that case. So clearly you can tell they're not like one another. So this is a definite here rejection of the null hypothesis. So reject HO. Great. Therefore, one of those stood out to be different. And you could say, oh, it was the medication group or it was the exercise group that came out to be completely different. And that is when you would do this pairwise comparison with ANOVA and doing another ANOVA of just those two groups to figure out like which one offset it. But I think clearly here you can tell that those aren't the same means there, in comparing what I have highlighted or circled there in blue. So again, wrapping this up here for the p-value, you're going to see that this is smaller than 1%. The probability that F, random variable F, is more than, again, for always a right tail. That's always going to be pointing to the right for F for this stuff, right? One-way ANOVA. The number that we got from that last one, that previous, was again going back to 11.0. Was it 11.07? Was it 04 or yeah, 0704? So let's place that back in, and we'll get something that is less than 1% for sure there. I wonder if I still have, no, I gotta put in the degrees of freedom and all that one more time, one last time here. Don't fail me now. All right, coming back here over to F, degrees of freedom of F1 there, or the numerator, the number of categories -1, so that's 3 minus 1 is 2, and then degrees of freedom within each one times the number of groups. Again, that's going to be 5 times 3 is 15. All right, so that's done for that one. Right bracket there, and place back in that answer the 11.0704, and then oops, 04. No, I want 40. What? No, did I? 0704. I think that is correct. Yeah. So I just have to change, put a 0 there, 0, 7, 0, 4. All right, click there in the right box. There it is. Yeah, less than, perfect there, less than that 1%. So we've got point, where's that, 0.0011. And of course that translates to a tenth, or I guess 11th of a percentage. Very small number there, you know, enough there in this case for statistical significance. So yeah, at least one of the groups stands out to be different. You could probably tell that the medication group doesn't look anything like the exercise group at all. One could suggest that probably the diet and the medication group are relatively close to one another, but again, you'd have to do a piecewise comparison there to break that down and see if, like, you know, if you just tied off and just compared the medication to the diet and then did a test of significance in that regard, you know, would it reject or not? Things like that nature. So what's, you know, that's the other thing here. It was a case that we were able to reject that they were the same, but what was it? What happened? What took place that really offset that? In today's research in the health community and things like that, if you really want to lower the blood pressure, you got to clean up the diet. Pretty much comes up to that. So I'm going to lean towards the diet. I think that's going to be a lot more important than the exercise group. That's just my opinion. Of course, consult your doctor and talk to them. Make sure you get a well-researched doctor that can help you out with all that stuff. Anyway, so this concluded here for ANOVA, analysis of variance here for section 13.2, one-way ANOVA. Wait. I don't want to end it here. Oh, one last thing. I forgot to do this for the last problem too. I just don't really want to extend out this video and have long goodbyes and stuff like that. But this was one of the good, you know, the calculators there I had on modules there. And I just want to point this out really briefly before I peace out here. So I had this link again on modules for ANOVA. That was the last one there. And what I went ahead and did was place in the data for all that. Ooh, looks like I'm going to have to clear that out for each one of those groups. Does it have my old p-value? No, it does not. Well, that's sad. And there's not a way to really clear this out. So let me go ahead and do that. Let me go and put in the data values and show you how to use this calculator. And just kind of parent, because I know there's a lot of statistical calculators out here. A lot of them, you know, especially would probably speed up this process by doing this for ANOVA. So I just wanted to point out this one. I'm not saying that this is the best ANOVA calculator. This is just one that seems to be web-based, therefore cross-platform, and you could do, like, you know, something like this with it. Certainly if you find one that you like better. And as long as it meets the requirements being FREE free, we're good to go. We'll use it. An app or whatever that is, even something maybe you found like another type of calculator on GeoGebra. Let me fill this in for group number 3 here. 4, 12, let's see, 4, so 4, 12, 4, 8, 9, and then last 6 there. Okay, let's go ahead and calculate and see what we can see. Okay, you could tell here, there's our numbers there for the means there for the medication, exercise, diet. We've got all that. What it's not going to tell us is the variance. You know, that's why I'm a little disappointed in this type of calculator though. But what it does do is does give us, look at that there. There's our answer for step number 5 and then step number 6 there. The standardized value, the 11 point, you know, that actually we came up with 11.0704. That's a little more accurate than that one, but you could tell that still gives us the same p-value at 0.0011 or 0.11%. The other thing I want to point out too is that those two numbers that I was dealing with when I did my division, that 88.3873 and the 7.9667, you'll recognize those two numbers. Let's jump back over here just for a second, back at the problem. let me go back over here. And that's why I highlight it there. There's those two numbers there. See where this is, the 88, this number here. That was that top one, and here's that bottom one there. Let me just jump back there a second, back to the, did I lose it? No, there it is there. So those are the two numbers that you want to divide, and then realize this 88.3873 number is the product of the sample size times the variance of the sample means. So naturally, in this case, all you need to do is take the 88.3873 and divide that by the 7.9667, and then you get, bam, and then that's where they get their standardized value, the 11.0946. So I just want to point this out, that, and then here is even nice. They just show the different bars there in comparison of the three different groups there for that one. Some formulas there at the bottom. So you can use this. This is a one-way ANOVA calculator. But you find one that you like better that actually displays everything there and the variance and all that stuff, and willing to yeah, trade up there. No problem. Okay, so there's my long goodbye. That's it. So this is for section 13.2, one-way ANOVA. Signing off here for chapter 13 for Math 25.